So this sheet titled Hyperbola Coming to Terms, application of things that we've already done. So we have a quadratic equation, x square plus 8px plus p minus 8px plus p minus 2 equal to 0. And we want to find the range of p for various situations. What if E1 is the eccentricity of the ellipse and E2 is the eccentricity of the hyperbola, for example? Then what would be the range of p, right? Now, very clearly, let's look at option A, and let me call this, say, fx. This quadratic expression is fx. E1 is the eccentricity of a ellipse, obviously has to be less than 1. E2 eccentricity of the hyperbola greater than 1. And obviously both greater than 0. Both greater than 0. That means this quadratic has roots, two roots, one less than 1 greater than 0, the other one greater than 1. This is given, right? Which means the graph of this function y equal to fx, this quadratic, it's an upward opening parabola, right? It's an upward opening parabola. And its roots must be like this: E1, E2, E2 greater than 1, but E1 less than 1. That means 1 must be positioned somewhere here. 1 must be positioned somewhere here, yes or no? Right? This is 0. Now, simple. Two conditions are: 1, f0 greater than 0, and f1 less than 0. Yes or no? We'll do the trick, right? f0 greater than 0 and f1 less than 0, isn't it? So f0 greater than 0 would mean what? P minus 2 greater than 0 or p greater than 2, and f1 less than 0. F1 less than 0, right? F1 less than 0 means 1 minus 8p plus p minus 2 less than 0, this condition along with this condition. So what does it give me? 7p greater than minus 1 or p greater than minus 1 by 7. So if I put both these conditions, p greater than 2 and p greater than minus 1 by 7, what would be one single condition? P greater than 2, p greater than 2. So both these, so this would be p greater than 2. Is option A p greater than 2? Okay, so A is correct, A is correct, p greater than 2, right? Let's look at B, right? E1, E2 are eccentricities of the hyperbola. That means both greater than 1. That means both greater than 1, right? Can I wipe this portion off? Huh? Both greater than 1. So now option B. Let's evaluate option B. That means 1 must lie somewhere here to the left. Now what do I have? F1 greater than 0 and F0 greater than 0. F0 greater than 0. Yes or no? F0 greater than 0, F1 greater than 0. Yes or no? But I'll tell you something. First of all, let me plug in both. F0 greater than 0, like before we'll get p greater than 2, right? F0 greater than 0 like before, and yeah, and F1 greater than 0, and F1 greater than 0 will give me what? P less than minus 1 by 7? What do I get? P less than minus 1 by 7? Can I have both these conditions together? No. No. So the roots of this can't be eccentricities of two hyperbolas, So option B is incorrect. I can't find a value of p. That means p is a null set here. P belongs to the null set, because I can't have both these roots as eccentricities of a hyperbola, isn't it? Because see, for that to happen, I would have had p greater than 2 and p less than minus 1 by 7. I can't have both. So p is a null set, belongs to the null set. No p, right? So option B. Now, E1 a hyperbola, E2 a conjugate hyperbola. Now, this is only a special case of this, right? In this also both E1 and E2 greater than 1. So if this is not true, how can this be true? Right? So this also null set. This also null set. Right? Now, E1, E2 eccentricities of an ellipse, of two ellipses. Right? That means what? That means one must be, let's say, to the right of both eccentricities. One must be somewhere here. You know? Now, it means F1. So, it means F1 greater than 0. Which gave me what? P? P less than minus 1 by 7, right? We got this earlier, right? And F0 greater than 0. F0 greater than 0. That means P greater than 2. No. Is this enough? Is this enough? Hey, this is not enough. Because if 1 was here, then also F1 would have been greater than 0. All that these conditions together tell me is that 1 is either to the left of E1 or to the right of E2. But in any case, it fails right here itself. Because in any case, what's the third condition? 1 must be greater than minus b by 2a. This line is minus b by 2a. See, if 1 was here, 1 would have been less than minus b by 2a, but we want 1 to be here along with these conditions. So 1 must be greater than minus b by 2a kind of a thing, right? So the third condition is 1 greater than minus b. That means 8p divided by 2. That means p less than 1 by 4. Now, do I get anything useful out of it? P less than minus 1 by 7. F0 greater than, does F1 greater than 0 give me this? P less than minus 1 by 7. P greater than 2. P less than, no, nothing. Yes or no? Nothing, no? Which means only option A gives me values of P, where one of the roots is the eccentricity of an ellipse, the other root is the eccentricity of a hyperbola, right? So we have a point P which moves along a hyperbola, that's given, and the coordinates of that point satisfy this equation, equal to 1 plus k square. We want to find the number of integral values of k for which P moves along a hyperbola, right? Now, what does this represent? This represents distance of xy from point 34. This represents distance of xy from 0, 0, right? Let's put together 2 points. 0, 0, and so let me call it S, prime, 3, 4. And then we have a moving point P, and we have S prime P minus SP. What is this? This is mod of S prime P minus SP. Yes or no? Right? Yes or no? And the difference of two sides has to be less than the third. This is difference of these two sides of a triangle, right? And this has to be less than the third. That means this has to be less than, this length is 5 units, root 3 square plus 4 square, this is 5. So this is less than 5. But mod S prime P minus SP, that's given to be 1 plus k squared. So 1 plus k squared is less than 5, or k squared less than 4, or k must lie between minus 2 to 2. So permissible values of k are minus 1. Integral values of k, minus 1, 0, 1. How many integral values of k? 3 integral values of k. Right? This problem is about this hyperbola x square by 4 minus y square equal to 1. Right? And the asymptotes of the hyperbola would be, as you can see, this equal to 0, y equal to plus minus x by 2, right? Y equal to x by 2 and y equal to minus x by 2. Now, I want to select a region from where if I draw tangents, it has to be to the same branch of the hyperbola. So obviously you realize that, you know, either in this region or in this region, if you select points, if you select a point here, you will be drawing tangents to this same branch. If you select a point here, you would be drawing tangents to this branch. But if you select a point here, then tangents to opposite branches would be drawn, right? Now they say select a point of the form 1 comma alpha, 1 comma alpha, and you want to be able to draw tangents to the same branch. I want to find the range of alpha for which this. Obviously, if alpha is very large, it will go outside this range, or very small, it will come down in this range. So obviously alpha is the y coordinate of this point. It has to be greater than the y coordinate of this point, but has to be less than the y coordinate of this point. Yes or no? Now when x is 1, when x is 1, y is half, so this point is 1 comma half, and from symmetry this point is 1 comma minus half, right? Very clearly alpha must be less than half but greater than minus half. Yes or no? So alpha belongs to minus half to half. That's the range of alpha. So this must be a, minus half must be a, and half must be b. So a plus b must be 0, as you can see. A plus b must be 0. You need the value of a plus b, right? Where the range of alpha is a to b. Where the range of alpha is a to b. And then out of comparison, you can say a must be minus half, b must be half. Their sum therefore must be 0. Right? So, you know, there is a moving point P. There is a moving point P. And there is this parabola y square equal to 4x. Y square equal to 4x is this parabola. And there is this moving point P, x1, y1. And from this, every position of P, I am drawing pair of tangents, PA and PB. Then AB would be my chord of contact. AB is my chord of contact. Now what we want is P should move in a manner that this chord of contact touches this rectangular hyperbola. For all positions of P, the various chords of contact produced would touch this rectangular hyperbola. That means it will be a tangent to this rectangular hyperbola. That's what we want. Right? That means, you know, if this is part of the rectangular hyperbola, this is what should happen. Right? So first of all, if x1, y1 is this point, then what's the equation of the chord of contact AB? T equal to 0, isn't it? T equal to 0. y1 minus 2 into x plus x1 equal to 0 is the equation of the chord of contact. That's the equation of the chord of contact AB, yes or no? Right? And what I want is this chord of contact AB must touch this, right? Now suppose it touches this now any point on this hyperbola is what? Sec theta tan theta, right? A and B are 1, sec theta tan theta, right? Right? And so there are two things. One, I can find the equation of AB as a tangent to this. What would that be? So the tangent at theta would be x sec theta minus y tan theta equal to 1. Is the equation of the tangent. And this line must be identical to this line. This line must be identical to this line. Right? And what is this line? This line is minus 2x plus y1 equal to 2x1. Yes or no? These two lines must be identical. Right? Therefore, their coefficients must be proportional. Now, coefficient of x divided by coefficient of x here. That means sec theta by minus 2 equal to minus tan theta by y1. Minus tan theta by y1 must be 1 by 2x1. Theta is my parameter. I need to eliminate theta and connect x1, y1 and then generalize. This is what I need to do. So this gives me sec theta, as you can see, is minus 1 by x1, right? Using this and this, and tan theta is minus y1 by 2x1. Sec square theta minus tan square theta is 1, right? So if I subtract, then sec square, I hope all of you understand what I did here. right? Sec theta by minus 2 is minus tan theta by y1 is 1 by 2 x1, right? So sec square theta minus tan square theta is like 1 by x1 squared plus y1 squared by 4x1 squared equal to 1. क्या हुआ बेटा? हाँ ये sorry right. So that gives me like a 4 minus y1 squared is 4x1 squared, or 4x1 squared plus y1 squared is 4. Generalize this. When you generalize this, you get 4x squared plus y squared equal to 4, or x squared by 1 plus y squared by 4 equal to 1. And what does it represent? An ellipse. That means this is the locus of P, right? x1, y1 are the moving coordinates of the point P. I go ahead and generalize the same. The locus of P therefore is an ellipse. This is an ellipse. Right, your attention please. So the next problem is about a point P selected on this rectangular hyperbola. And from this point, two tangents are drawn. Say PA and PB, to the ellipse x square by 9 plus y square by 4 equal to 1. One of the tangents makes 60 degrees with the positive direction of the x-axis. We want to find the angle theta made by the other tangent with the x-axis. This is what we want to find. You understand the problem? I select a point P on this, and from this point I draw a pair of tangents. And one of the tangents makes an angle 60 degrees with the x-axis. I want to find the angle theta that the other tangent makes with the x-axis. This is what I want to do, where P is a point chosen on that rectangular hyperbola, right? Now, first of all, what would be the form of any point on this hyperbola? Can I say any point on this hyperbola will be of the form root 5 sec theta, root 5 tan theta? Can I say this? This would be the point P. Root 5 sec theta, root 5 tan theta would be any point on this rectangular hyperbola, right? Now, so essentially, we are talking about tangents that pass through this point. We are talking about tangents drawn to this ellipse that pass through this point, right? Now, any tangent to this ellipse must be of the form of, hey, you know this, y equal to mx plus root a squared m squared plus b squared. Must be the form of any tangent drawn, right? This would be a tangent of slope m. In this case, a squared is 9, b squared is 4. Now this tangent, for some values of m, will pass through this point? Yes or no? So this tangent passes through this point P, root 5 sec theta, root 5 tan theta, right? So root 5 tan theta, right? Root 5 tan theta, why is root 5 sec tan theta is m into root 5 sec theta plus root a squared m squared 9m squared plus b squared 4, right? Yes or no? Okay, let me not call this theta, then let me call this some other angle, because theta is about the eccentric angle of this point, so let me call this tan alpha, right? Otherwise the variables will conflict. Now this gives me like a root 5 into tan theta minus m sec theta equal to root 9m squared plus 4. Hey, do you realize when I square this, I'll get a quadratic in m? One m will be m1, the slope of this, the other m would be m2, the slope of this tangent. Yes or no? Hai na? So let me square this to create a quadratic in m. So 5 into tan theta minus m sec theta whole square equal to 9m squared plus 4. right? So this gives me 5 sec square theta minus 9 m squared. I'm writing this as a conventional quadratic in m. Minus 10 m 10 sec theta tan theta into m plus 5 tan square theta minus 4 equal to 0. Equal to 0. Quadratic in m. And what would be the roots of this quadratic? Slopes of these two tangents. So m1, m2. Where m1 is tan 60 degrees. m1 is tan 60 degrees, I know. I want to find m2. Hey, m1, m2 is this by this? Yes or no? 5 tan square theta minus 4 divided by 5 sec square theta minus 9. Huh? Yes or no? What's the value of this expression? What's the value of this expression? If I write, bolo, you write tan square theta, I can write as sec square theta minus 1. So this will become 5 sec square theta minus 5 minus 4 minus 9. Numerator denominator will get cancelled. It's 1, right? Yes or no? So m1 I know is tan 60 degrees. m1 is tan 60 degrees. Right, absolutely. m2 must be tan alpha and the product must be 1. The only possibility is alpha must be 30 degrees. Alpha must be 30 degrees because, isn't it? Then it will become cot 60 degrees into tan. So alpha must be 30 degrees. Pi by 6 is alpha. Right? Next problem is about a hyperbola with eccentricity E, and the eccentric hyperbola has eccentricity which is a function of E, right? And we know the property is 1 by E squared plus 1 by Fe squared is 1, isn't it? Relationship connecting the eccentricities of the hyperbola and its conjugate, right? 1 by E1 squared plus 1 by E2 squared is 1. So that gives us f of E equal to E by root E squared minus 1. That's f of E. Eccentricity of the conjugate hyperbola. Now, what is f of E? Replace E by f of E, right? So, E by root E squared minus 1 divided by root E by root E squared minus 1 whole squared minus 1. And that you can see is E. That you can see is E. Which means now f of E is E. If you apply one more f, then again it will be, right, this. So f of E, one more. So thrice. So once it's going to be this, twice it's going to be E. So one more time it's going to be repetition of this. So that's going to be E by root E squared minus 1. 3 times. If you apply it 4 times, that's again going to be E. So the very simple. If f appears an even number of times, it's going to be E. If f appears an odd number of times, it's going to be E by root E squared minus 1. Yes or no? Now this. So when n is even, this is simply going to be E. F of etc. is going to be E. So this integral is going to be integral E dE 1 to 3. And when n is odd, then this is going to be E by root E squared minus 1. Right? When n is odd, see once, thrice, 5 times, etc. It's going to have e by root e squared minus 1, e by root e squared minus 1, and so on and so forth, right? So when n is odd, then this integral is going to be e by root e squared minus 1 dE. E runs from 1 to 3. How does one integrate this? Right, right. So this is like 2e half, and this is e squared minus 1 to power minus half dE. Function raised to a certain power into the derivative of the function, isn't it? Function raised to a certain power into the derivative of the function. So that's going to be 1 to 3. Okay, so that's going to be half of e squared minus 1 to power half divided by half. E runs from 1 to 3. This is what it's going to be. At e equal to 1 at 0, e equal to 3, 9 minus 1, 8, 2 root 2, 2 root 2. So every time n is odd, this becomes 2 root 2. Every time n is even, it's going to be this, e squared by 2. 4, 9 minus 1, 8 by 2, 4. Right. X squared by 9 minus y squared by 16 equal to 1. Alright. And with one focus as the center, a circle is drawn touching the hyperbola, right? And I want to be able to find the radius of that circle. And no part of the circle lies outside this hyperbola. No part of the circle is meant to lie outside the hyperbola. So the center of the circle, let's say, is 1 of the foci. And of course, this point, as you can see, is going to be 3, 0. Yes or no? This point. 3, 0. Okay. What is the eccentricity of this hyperbola? 1 plus 16 by 9. So E is 5 by 3. Focus S is going to be AE0. A is 3. So S is 5, 0. So this focus is 5, 0. Now, look, suppose the circle looks like this. Suppose the circle looks, sorry, it's a badly drawn circle. But suppose the circle is like this, touching the hyperbola at this point. Touching the hyperbola at a point theta, right? Then, what it really means is, at this point they have a common tangent, and therefore they must have a common normal. That means the normal to the hyperbola at theta, must pass through the focus, because it will also be a normal to the circle, right? Now, what gives me the normal to the hyperbola at any x1, y1? x1 by a squared plus y by y1 by b squared is a squared plus b squared is the equation of the normal at any x1, y1. So what would this give me? X by x1 is a sec theta. So this gives me a is 3. So 3x cos theta plus y1 is b tan theta, right? So by cot theta is a square plus b squared. That's a normal at any theta. A square plus b squared means 9 plus 16 means 25, right? The normal at any theta. And I want this normal to pass through 5, 0. Let's see if it's possible. That means 5, 0 satisfying this equation. That means 3 into 5 cos theta must be 25. Cos theta is 5 by 3. God damn it. How is that possible? Not possible. That's just not possible. Is that possible? Not possible. That means, of course, I am assuming that theta is not 0. But there is a second possibility. So, for sure, I can't have a non-zero theta giving me meeting the required conditions, right? So this is not possible. What is possible? The following is still possible. And this will be the common normal. This is possible. A circle with center 5, 0 and radius 2. A circle with center 5, 0 and radius 2. That means the point of tangency is 3, 0. Common tangent is 3, 0. They'll have a common tangent at the vertex. So the radius of the circle is 2. right? Radius of the circle is 2. Do you realize that? Hmm? The next problem is about this hyperbola y squared minus x squared equal to 1. And I select a point on this hyperbola with x coordinate n. So y coordinate would be very clearly root n squared plus 1, right? And now there is this line y minus x equal to 0. dn is the shortest distance of this point from this line, and I want to be able to find limit n dn as n tends to infinity. I want to find this, right? Now what is dn from distance formula? dn is going to be, put y equal to this number, root n square plus 1 minus x, which is n, divided by root 2. And I don't have to put a mod here because this number is anyways more than this. So I don't have to put a mod, right? Now limit n dn means limit n into root n square plus 1 minus n divided by root 2 as n tends to infinity. Obviously, you want to rationalize this. You want to rationalize this, right? N into, so we have n square plus 1 minus n square, which is 1. I'm rationalizing this. Divided by root 2 into root n square plus 1 plus n. N tends to infinity. Now you can take n square common from this. Right? Now you can take n square common from this. So limit n divided by root 2 n square, matlab n common means root 1 plus 1 by n squared plus 1 as n tends to infinity. 1 plus 1, 2. So that makes it 1 by 2 root 2. 1 by 2 root 2. Clear? Next one is about this hyperbola x square by 4 minus y squared by 9 equal to 1. From the center of this hyperbola, which we know is the origin, right? For this hyperbola, center is the origin, standard hyperbola. We draw two lines, CP and CQ, that are perpendicular to each other, right? We want to be able to find the value of 1 by CP squared plus 1 by CQ squared. Now, let's say, so obviously, you know, this CP is a variable essentially, because for the different thetas, I'll get different CPs. Apparently, it seems like this should be independent of theta. I'm forced to believe that this might be independent of theta, right? So what we do here is, CP says R1 and it makes an angle theta. So the coordinates of P would be R1 cos theta, R1 sin theta. This is not the eccentric angle, by the way. This is the polar angle of the point P, right? This is not eccentric angle. Cos theta, R1 sin theta. Now, for Q, instead of R1, you have R2, and instead of theta, you have theta plus 90 degrees. You have theta plus 90 degrees. So replace R1 by R2 and theta by theta plus 90. So coordinates of Q would be R2 minus R2 sin theta and R2 cos theta, isn't it? You know what I did? Replace R1 by R2 and theta by 90 plus theta. Yes or no? Right? Now, this lies on the hyperbola, will satisfy the equation of the hyperbola. So, R1 cos theta whole squared by 4 minus R1 sin theta whole squared by 9 must be equal to 1. This is 1 by R1 squared. So, if I can find 1 by R1 squared is cos square theta by 4 minus sin square theta by 9, right? Yes or no? Now, similarly, this point also lies on this hyperbola. So what do I get? R2 minus R2 sin theta whole squared by 4 minus R2 cos theta whole squared by 9 equal to 1, right? So this gives me 1 by R2 squared as sin square theta by 4 minus cos square theta by 9. Yes or no? If I add these two, then this will give me 1 by 4 sin square theta plus cos square theta, 1, minus 1 by 9 sin square theta plus cos square theta, 1. So what do I get when I do a 1 by R1 squared plus 1 by R2 squared? I get 1 by 4 minus 1 by 9, which is 5 by 36 is what I get. Yes or no? Clear? So essentially what we are doing is, this is the hyperbola x square by 9 minus y square by 4 equal to 1. Alright, please understand this. And I'm very confident you would have forgotten this property, but nevertheless, the property is that if you draw any tangent, it intersects the tangents at the vertices, say at P and Q. Now, the property that I mentioned was P, Q, S prime and S are concyclic points. P, Q, S prime and S are concyclic points. Right? Recall this? Now, what circle are we talking of? We are talking of a circle that passes through S, S prime, P and Q. We are talking of a circle that passes through P, Q, S prime and S. Right? Now, the other property. So this is one property. This other property that I mentioned was that PQ will subtend a right angle at the focus. That was the other property. PQ will subtend a right angle at the focus. That means PQ must be the diameter of that circle. PQ must be the diameter of the circle passing through PQ, S prime and S. Yes or no? So the circle in question is this very circle whose diameter is PQ. Right? Now, what are P and Q? P and Q are intersection points of the tangent at this point with the tangent at the vertices. The tangent at the vertices are x equal to minus 3 and plus 3. Right? What's the equation of the tangent at 6 comma 2 root 3? X, x1 by 3 minus y, y1 by 9 by 4. I'm sorry, x1 by 9 and by 4 equal to 1. That's the equation of this tangent. Now can you find the coordinates of P and Q? Yes. Intersection with x equal to 3 and x equal to minus 3 will give you the coordinates of P and Q. If you plug in x equal to 3, you get the y coordinate of P. The x coordinate of P is 3 only. The x coordinate of Q is 3, minus 3. So if you plug in x equal to minus 3, you get the y coordinate of Q. So you know the coordinates of P and Q. And the goddamn circle has PQ as its diameter. That means the midpoint of PQ must be the center of that circle. XP plus XQ by 2, YP plus YQ by 2. That will be the center of the required circle, the midpoint of PQ. What do you say? Right? So this was again a property, you know, I mentioned this property, you've forgotten about this, right? But this is an important property.